Modern cities are designed to function above ground. Schools stand above streets. Power plants sit in open industrial zones. Electrical substations connect cities through visible networks of towers and cables. Hospitals are large buildings that can be easily located on a map. For decades, this layout worked because cities were built around accessibility and efficiency. But when a country begins to face constant missile and drone attacks, that design becomes a vulnerability. Since 2022, Ukraine has experienced repeated strikes targeting energy facilities, infrastructure nodes, and public buildings across multiple cities. Power plants, heating stations, electrical substations, and transportation systems have all been damaged or destroyed at different points during the conflict. These facilities are large, fixed, and easy to identify from satellite imagery or reconnaissance drones. Once their locations are known, they can be targeted again and again. This forced engineers and city planners to confront a difficult reality. Infrastructure built entirely above ground is extremely exposed during modern warfare. In response, Ukraine began adapting its infrastructure to reduce this exposure. One of the most visible changes has been the construction of underground or heavily reinforced schools. In several regions, new educational facilities are being built partially below ground level. These structures are designed with thick reinforced concrete shells capable of absorbing blast waves and protecting interior spaces from debris. Unlike traditional bomb shelters that exist only for emergencies, these underground schools are designed to operate as full educational environments. They include classrooms, ventilation and filtration systems, independent electricity supply, emergency exits, and protected communication networks. The objective is practical rather than symbolic. Allow students to continue learning even when air raid alerts interrupt normal daily life. In many cities, children previously had to spend hours in basements or shelters whenever alarms sounded. By integrating protective structures directly into school design, the time lost to constant evacuation can be reduced while maintaining safety. Metro stations become some of the safest places in the city. In Kiev and Kharkiv, many platforms sit 20 to 40 meters below ground, protected by thick layers of soil and reinforced concrete tunnels. During bombardments, thousands of civilians move underground. Platforms turn into temporary living areas where families wait out air raid alerts. Cities equip the stations for long stays. Power outlets and charging stations are installed along the walls so people can keep their phones running. Heating areas and points of invincibility appear where residents can warm up, drink hot tea, and access electricity during blackouts. Volunteers bring water, blankets, and basic supplies. Mobile internet and communication systems help people stay connected with the outside world. At the same time, the metro already contains many of the features required for a large shelter: reinforced concrete tunnels, multiple entrances and escape routes, powerful ventilation systems, and independent power lines. Infrastructure designed to move millions of passengers effectively becomes a protected underground refuge for the city above. Energy infrastructure becomes one of the hardest systems to protect. Power plants and substations are critical for modern cities, but they are also large, fixed, and easy to identify from the air. During the war, these facilities quickly become major targets. A single strike can disable large sections of the grid when electricity is concentrated in only a few locations. Engineers begin changing how the system works. Instead of relying on a few massive plants, electricity is spread across smaller distributed sources. Mobile generators are deployed across cities and critical facilities to restore power quickly when the grid is damaged. In some areas, overhead transmission lines are replaced with underground cables, making them harder to destroy from the air. Transformer stations and control centers are reinforced or moved into protected structures. The key principle is redundancy. If one node fails, the rest of the network continues operating, reducing the risk of a total blackout. Hospitals and medical facilities have also adapted to this environment. Some hospitals now include reinforced underground sections designed to protect critical medical operations during attacks. These spaces can house emergency surgery rooms, intensive care units, and medical supply storage areas, that must remain operational even during power disruptions or air raids. Underground hospital sections are typically equipped with independent electrical generators, ventilation systems, and secure communication lines so that treatment can continue if surface infrastructure is damaged. In a similar way, command centers responsible for managing emergency response and infrastructure operations often function from protected underground locations. These sites allow coordination between energy networks, emergency services, and government agencies, even during large-scale attacks on urban areas. These engineering changes do not eliminate risk, but they make the system far more resilient. Infrastructure that exists only on the surface can be disabled quickly. Systems that are distributed, reinforced, or moved underground are much harder to destroy and easier to keep running during prolonged attacks. In Ukraine, this approach is reshaping parts of the urban system. Schools operate in protected buildings. Metro tunnels function as both transport and shelter. Energy networks are becoming decentralized. Hospitals and command centers move critical operations underground. The result is not an underground city, but a hybrid one, where essential systems are protected below the surface while everyday life continues above it.